GoDigitalSA Foundation, and today we're doing Unit 11, Arrays. So Lesson 8, Understanding Arrays. We'll be looking at About Arrays and Sorting Arrays. And here's just a reminder, you remember that we talked about types of variables. We've got numbers, strings, booleans, sprites, and then we've got arrays. An array is a list of multiple items, and it can be a list of numbers, it can be a list of strings, and it can be a list of other things. So an array is a list or a collection of similar things, like a rock or coin collection. What are some examples of arrays in everyday life? It's whenever you've got a collection of anything. Here we've got a collection of different colors of paint. Here we've got different cupcakes. Here we've got books. Here we've got collection of eggs. So in programming, you can think of arrays as a list of individual variables with the same data type. Arrays can store numbers, strings, or words, sprites, and even musical notes. Okay, array index. Every spot in an array can be identified by its index, which is a number that corresponds to its spot in the array. The first spot in an array is always at index 0. Okay, so if we look at our collection of rocks here, the first position is spot 0, so the index is 0. The next is spot 1, so the index is 1. So 2, 3, 4. The length of an array refers to the total number of items in the array. The length of our rock collection array is 5. So we've got 1, 2, 3, 4, 5 positions for rocks. So the length of this array is 5. The index of the last element in an array is always one less than its length. And that's because the array numbering starts at 0. Okay, so if our array goes from 0 to 4, that means that the length of the array is 5. Arrays in MakeCode. In MakeCode, you can find the array blocks in the advanced toolbox area. You use the set blocks to create arrays of numbers or strings. Okay, so in our toolbox here, we have to go to Advanced to find arrays. Okay, and in arrays, we'll see we can set a variable to an array of numbers, and we can set a variable to an array of strings. We can find the length of an array. We can find the value of an item in an array at an index, and so on. Okay, so here we've got one variable that we've set to an array of numbers, and here we've got another variable which we've set to an array of strings. Okay, let's discuss who collects something and what do you collect, and how big is your collection, how is it organized, and are the items sorted in any way. Okay, so think of things that you might collect and put into a list. How would you find a particular item in the collection? Okay, so to review, length is the total number of items in a collection. Sort, items in the collection are ordered by a particular attribute, for example, date, price, name, and so on. Index is a unique address or location in the collection. And type is a type of item being stored in the collection, like a number, a string, and so on. Okay, let's talk now about sorting information. Sorting information is useful for many reasons. How can we sort a list of learner applications? Okay, so here we've got a list of learner applications. We've got a name, an age, a score for some sort of test, a date that the application was received, the name of the school that the learner goes to. So how would you sort this list by date? Okay, so let's say we want to rearrange this by date. You can see that this is September 1st, September 11th, August 29th. But we want to sort it by date. What will we do? We might look through the list, look for the smallest one. August 28th is the first date, so we move this one to the top of the list. Then we go through the list again, look for the next one, August 29th. Next one is September 1st, and so on. Okay, so do you have a technique for sorting, or do you do it by eye? So I was just doing it by eye there. I wasn't using any particular technique. Computers use algorithms to do things. There's more than one algorithm for sorting data. The best algorithm is the fastest one, or the one that uses the least RAM, and so on. So there are more than one algorithm. Okay, and here we're just looking at sorting this list in various ways. This is now sorted by age. This is sorted by the score. This is sorted by date. And this is sorted by the name of the school. Okay, so sorting algorithms. In computer science, there are some common sorting algorithms. Okay, sorting is such an important thing that there's many different ways of sorting, and the most popular ways have got names. So we're going to look at the bubble sort, the selection sort, and the insertion sort. Okay, in bubble sort, this is the algorithm. So we're going to start with a list of numbers. Here we've got 5 numbers that we want to sort. So we compare the first 2 boxes. If the box on the right has a smaller number than the box on the left, they should swap places. Okay, so if we look at these two, this is 5, this is 1. 5 is greater than 1, so we're going to swap the places. So now it's 1, 5. Next, we compare the second and third boxes. If the box on the right has a smaller number than the box on the left, they should swap places. So now we've got 5 and 4. So 5 is bigger than 4, so we swap them. So now it's 4, 5. Okay, and we carry on like that until we reach the end. So 4, 5, 5, 2, 5 is greater, so we swap them. So now it's 2, 5. 5 is smaller than 8, so we don't swap them. So we're left with 1, 4, 2, 5, 8. Okay, so after reaching the end, we have to start all over at the beginning again. Okay, so you see we start at the beginning now. So 1 is smaller than 4, so we don't swap. 4 is bigger than 2, so we have to swap those. So now it's 2 and 4. 4 is smaller than 5, so we don't swap those. 5 is smaller than 8, so we don't swap those. Okay, so now we're left with 1, 2, 4, 5, 8. Okay, so we continue in this way until we make it through the entire row of boxes without swapping anybody. Okay, so we have to start again for our third pass. We check the first 2, there's no swap. Check the next 2, there's no swap. Check the next 2, there's no swap. Check the next 2, there's no swap. So we haven't changed the order, but we know now that because we've gone through all of them and there's no more swaps to be made, this is now finished. We've sorted this list. You can see it's 1, 2, 4, 5, 8. That's in order. Okay, and we can let's take a look at how we would code this in MakeCode. So I'm going to go to MakeCode to save time. I've got it here. Here's our bubble sort. Okay, and it's quite complicated. Okay, on start, I'm going to show the letter B to show that this is the bubble sort. We've got 2 variables, index and column, that we set to 0. And we'll start with a list, and it's just going to be an array of numbers. I've just picked 4, 2, 5, 1, 3. We want to sort those numbers. Okay, and so we start by setting a counter to 1. Okay, when we press button A, we do our sort. Okay, so while the counter is greater than 0, we set the counter to 0, and then for index 3 from 0 to 3, if the item in box 0 is greater than the item in box 1, we set a temporary variable to the item in box 0. We set the item in box 1 to the item in box 0. And we set the item in box 0 to the temp variable. So what we've done with these 3 is to swap the 2 values around. Okay, and then we increase the counter by 1. Okay, so that was if the item in box 0 was greater than the item in box 1. Okay, so that's done our swap for the first two boxes. We cleared the screen. Okay, and now this is just to display the values so we can see how we are sorting. Okay, so let's just try this now. So when I press button A, it's going to do this sort on the list, and then it will display it. Okay, button B clears the screen and displays the values. We're going to plot it. Okay, so let me press button B, and this is the values in our array. And you'll see that I set it to 4, 2, 5, 1, 3. So it's 4, then 2, then 5, then 1, then 3. Okay, so if I press A, it should sort these in order. Press A. Okay, and now you can see that they're in order. Okay, and we've coded on button A and B is pressed. We're going to pick a set of random numbers. So we're going to change these values to a new set of random numbers. So I press button A and B to create a set of new random numbers. Button B will display them, and button A will sort them. Okay, and you see again, it's sorted. Okay, so that is the bubble sort. Right, the next sorting algorithm is the selection sort. Okay, this gets a bit more complicated, but it is a faster sort. So here we've got a list of numbers, and because this is a better sort, we're using bigger numbers and a longer list for our example. So here we've got 2, 4, 6, 8, 9 numbers, and you can see they're in random order. So the selection sort, we take the first box on the right and consider that box's number to be the largest number we have found so far. Okay, so we're saying that 36 is the largest number so far. So if the next box in line has a number that is larger than that, then you make that box's number the new largest number. And we continue until we reach the end of the line. Okay, so we look at the next box, 51. So that's greater than 36. So that's our largest number. Next one is 52. So that's larger. 66, that's larger. 87, that's larger. 13 is not, so we ignore it. 98 is larger. 72 is not larger than 98. 29 is not larger than 98. So after going through the whole row, we swap the last box with the largest number. So we're moving 98 to the end and moving 36 to take its place. Then move the box with the largest number all the way to the right. Then we start over at the second box from the right. Okay, so we've done that with the first row. So now we're starting again, but we're going to start at this position because we know that this is the largest number. So we got 51. Now we got 52. So now 52 is the largest. 66. So 66 is the largest. 87 is the largest. 13 isn't. 36 isn't. 72 isn't. 29 isn't. So we're going to take 87 and swap it with 51. So you'll see now that 87 is there. 51 is there. Okay, so now we're going to start this position and do the same thing. Okay, so we go through this row looking for the largest number, and when we reach the end of the row, we swap the largest number with that position. So now the 72 goes here, and the 52 is here. Now we start here, go through the row. In this case, 66 is the largest, so nothing gets swapped. Here, we go through the row, 51, we find 52 is the largest, so we swap. We start over here, go through here, 51 is the largest, so we swap. Start here, 36 is already the largest, so we don't do any swapping. Over here, 29 is the largest, so we swap. And now we've reached the end. Okay, so let's try this in MakeCode. Okay, and again, I've saved this one. Okay, so this is the selection sort example. Okay, again, on start, we set our variables. We're going to take these numbers, 4, 2, 5, 1, 3. I'll display an S to show that this is going to be our selection sort. When we press button A, it's going to go through the list as we showed before. It's not too important to remember exactly what it's doing here. What's important to see is how long it takes. So when I click A, do you see how quick that was? So again, we can create a new set of numbers by pressing A plus B, press B to display them, and now when we sort, you can see that there's far fewer steps. So the selection sort is much faster than the bubble sort. Okay, and finally the insertion sort. Okay, and this is just another sort. We don't have to really worry about the details. It's just another fast way of sorting. Okay, and if we take a look at this in MakeCode, you can look at this if you want. You can pause and look at the instructions, and you'll see how this sort works. So now let's try that in MakeCode. Okay, so this is the insertion sort. Same thing, on start, I'm displaying the I to show that this is an insertion sort. We start off with this set of numbers, press B to display it. So you see it's 4, 2, 5, 1, 3, 4, 2, 5, 1, 3. Now when we sort, okay, that's sorted. We can create a new set of random numbers, display them. Okay, so you can also see that this is much faster than the bubble sort. Okay, so what we learned, arrays and different methods of sorting arrays. Next time we'll code with arrays, and then we'll assess our learning with a quiz. Okay, so lesson B is coding with arrays. What we'll learn, we'll use arrays to store both string and numeric elements, and we'll see that there's a special loop block for arrays. And then we'll review what we've learned. Okay, so we'll code a game called Headband Charades. We'll create an array of words that will be used as prompts for a charades game. Okay, this game was inspired by the Heads Up phone game. So our pseudocode is create an array of 6 random words for the charades prompt. Okay, when you tilt the microbit up, show the word at the current index. When you tilt the microbit down, it increments the array index. Okay, so we want to tilt the microbit up to display a new word, and then we play charades for that word, and then we tilt it down to go to the next array index. Okay, the program might look similar to this. Okay, and we'll look at it in MakeCode. It'll be easier to see in MakeCode. And some modifications we could add to it. We could make a headband to hold the microbit on to the player's foreheads. You can use paper, rubber bands, and so on. And we can add ways to keep score, keep track of the number of correct guesses and passes, and add a time limit. Okay, so let's open a browser and start coding. Okay, so this is Headband Charade. Again, to save time, I've saved it. Okay, so on start, we create an array. We've named it text list, and it's an array of cat, guitar, flashlight, cupcake, tree, frisbee. And we've got a variable index, which we set to 0. So to start, we're going to display a question mark and pause for 1/10 of a second. Then we'll count down, display 3, pause, 2, pause, 1, pause. Then we clear the screen. And we show the first word in that list. So we show string, text list, get value at index. Index is 0. We've set index to 0, so it's going to show this first value in the list, which is cat. Okay, I'll stop and start. You'll see it counts down, and then it displays cat. Okay, so you play charades. People have to guess the word cat. And I've used button A and button B instead of tilt up and tilt down because the simulator isn't very good with showing tilt up and tilt down. Okay, so when I press button A, that's like tilting up. It shows the word cat. When I press button B, I want to stop whatever is happening, clear the screen, and then if index is smaller than the length of the array minus 1, then I change the index by 1. So in other words, if index, okay, the first time through, index is 0, so that will be smaller than the length of the array. The length of the array is 1, 2, 3, 4, 5, 6. Okay, so that's index 0, 1, 2, 3, 4, 5. So if index 0 is less than the length, 6 minus 1, which is 5. So if index is less than 5, then it changes the index by 1. So adds 1 to the index, so now index is 1. Okay, so that's what happens when I press button B. Okay, and then when I press A, it's going to display, it's going to show the string at index, where index is now 1. And you'll see that it displays guitar. Okay, so you play charades with that. People have to guess guitar. And then for the next one, press B. It increments index. So now we get flashlight. Okay. Play that round, press B, that increments index. Now we get cupcake. Press B. Now we get tree. Press B. Now we get frisbee. Okay, so the next time I press B, index is 5, so it's no longer smaller than the length. The length was 6, so 6 minus 1 is 5, so 5 is not smaller than 5. So this time it's going to do a game over. And game over is just something that the microbit does to show you that you're at the end of the game. So let's see what happens. Okay, so that shows that the game's over, and it wants to show you that the score, we haven't been keeping a score. That's one of the modifications we can make. So it just shows that the score is 0. Okay. Okay, so that was one example of an array. Here we've got another example, Starry, Starry Night. We create a set of random constellations on the microbit screen. We use an array of numbers to determine how many stars or LEDs to turn on. Okay, so hence, use a for loop from 0 to the last index value in your array to move through your array of constellations. Use the plot block with the pick random blocks to turn on a random star or LED on the microbit, and use a repeat loop to turn on the correct number of stars for each constellation. Okay, the program might look similar to this. Okay, so we'll take a look at this in MakeCode. Okay, so this one we called Starry Night. Okay, so on start, I create a list, and it's 1, 2, 3, 4, 5 random numbers. Okay, so when we press button A, it's going to use this variable index from 0 to 4. So index starts off at 0. So it's going to repeat using list. We get the value at index. So we're going to repeat list number of times. So index is 0, 0 is 5, so this is going to be 5. So it's going to repeat this 5 times. It's going to plot 5 random LED positions. It then pauses for a second, and then it clears the screen. So next time around the for loop, index is 1. So it's going to get the value where index is 1, so that's 10. So this will be 10, so it's going to go around this loop 10 times, plotting 10 random LEDs. And then it pauses for a second and clears the screen. And it will do that until it reaches index 4, which is 4. Okay, so we'll see that with button pressed A. Okay, so you see it's just plotting random constellations. Okay. Okay, and now we want to look at a different type of block. Instead of using the regular for loop block, MakeCode provides a special for loop block specifically for arrays. We've seen in loops, we had the repeat loop, the while loop, the for index from 0 to for loop. Now we're going to look at the for element value of list loop. So this loop will go through every item in a list. And so let's just take a look at how that works. Okay, on button B here, I'm using that instead of the for index from 0 to 4, I'm using for element value of list. So list is this list of numbers. So we're going to go through the list using each value. So the first time through the list, it's using 5. So it's going to repeat 5 times, repeats that 5 times, pauses, clears the screen. Then it goes to the next value, 10. So value is 10, repeats that 10 times. Then 17, so repeats that 17 times. Then 9 times, then 4, so 4 times. Okay, so this does exactly the same as this, but it's using the special for element value of list instead of using for index from 0 to 4 and then getting the value out of the list. Okay, so on button B pressed, that's how it looks. So it's doing exactly what it was doing, but just using a different method. Okay. Okay, let's have a quick quiz. How would you define the following terms? Array length, array sort, array index, and array type. So array length, the total number of items in a collection. Array sort, how you could order items in the collection, for example, date, price, name, color, and so on. The most common types of array sorts are bubble, selection, and insertion. There are many others. Array index is a unique address or location in the collection. For example, the page number in an album, a shelf on a bookcase, and so on. And array type, it's the type of the item being stored in the collection. So here they're using comics, $1 coins, Pokemon cards, numbers, strings, and so on. Okay, an array has to be a collection of the same type of thing. So we've looked at string arrays and number arrays. You can also have object arrays and other types of arrays, but all the items have to be the same type. How are array variables different from other variables? Most variables are used to store a single value. An array can be used to store many values in one place. You can think of arrays like a list of items, like a row of mailboxes or a train of container boxes, and so on. Where do you find the array blocks in MakeCode? It's under the Advanced Toolbox menu. To create an array in MakeCode, what do you need to assign it to? A variable. Okay, so we always use variables, and we have to create a variable and then we assign an array to it. So what we learned today, we used arrays to store both string and numeric elements. Okay, so next time we'll code and make a microbit musical instrument. So this will be your project. Make a microbit musical instrument. Okay, we'll create our own microbit musical instrument using arrays. Okay, to create a musical instrument that uses arrays to store sequences of notes. The array of notes can be played when an input occurs, such as one of the buttons being pressed, or if one or more pins is activated. Ideally, the microbit should be mounted in some kind of housing, perhaps a guitar shape or a music box. You will need to connect your microbit to headphones or a speaker to play sounds. Okay, so these are examples. We've got a microbit guitar. It uses a microbit accelerometer to play different tones when the guitar is held and tilted while playing. Pressing the A button will save the current tone to an array. After 10 tones, a repeating melody will be performed. Then you press the B button to clear the array and start over. Okay, so this lets you record what you're doing into an array, and then it will save 10 different tones, and then it will repeat those tones by reading them out of the array. Here we've got a banana keyboard. This uses the pins connected to pieces of fruit to activate the music. So instead of a guitar, you can use bananas or fruits. Okay, so for the project, you use a design thinking approach and ensure the project meets these specifications. It uses at least one array in a fully integrated and meaningful way, and the array stores and iterates through each element of the array successfully. The tangible instrument is tightly integrated with the microbit, and each relies heavily on the other to make the project complete. The program compiles and runs as intended and includes meaningful comments in code. Okay, so what we learned for our project, we made a musical instrument using arrays. Okay, so next unit will be Unit 12, and that is the final project. So I'll see you next time.